inhliziyo yami ifuna bangawena nayakho inhliziyo ifuna ringangena asijabule 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 stand yourself asijabule 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 stand yourself asijabule 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 stand yourself asijabule.
Hello, everyone. Welcome to today's PPL. I'm really happy to have you all here. I hope you are doing well and ready to learn, ask a question, and explore together. So today we'll be diving into the Gaussian mixture models, which is a really interesting topic in data science, or rather machine learning. So meet your host. I am Nozi Pumate. I'll be here with you till the end, and then we have our data scientist, our technical mentor, Shegun Lawal. He will take us through this interesting topic. I hope you are ready to learn. But before we dive into the session, let's just go to the rules of engagement. If you have any questions, please post them on the Q&A section. Feel free to use the chat liberally and respectfully. Listen, learn, and engage. So I'd like to welcome Shegun. Please give him some love. Show some emojis on the chat. Show some emojis. Can I see them flying? Because he will do an amazing job today.
All right. Thank you, Nozi. Good everyone. My name is Shagun Lawal. Apologies if you're expecting to see Mbali's face. Mbali had some emergencies to attend to, so I'm standing in for her. I hope you're all doing great. As I was introduced, my name is Shagun Lawal. Hold on, fun fact about me. What's one fun fact about me? Okay, so this is a fun fact about me. So I used to be a Manchester United fan. In 2013, for those of you who remember, Alex Ferguson retired from Manchester United. So I knew Man U would go through a dry spell, but I didn't expect it to be this long. So I took a sabbatical, like a long sabbatical for Manchester United. So typically, if you're a Manchester United fan back in 2013, you know that by affinity or proximity or priority, you would definitely like Real Madrid, right? So I was keeping myself busy with Real Madrid. And for those of you who follow football, the last 2 years has not been cool for Real Madrid. So I've really been a neutral right now. I think the last two Champions League finals, I enjoyed watching it because I didn't care who won, who lost. I was just enjoying football. Football is sweet when you are a neutral. It's tense when you are hoping your team win. Yeah, with what Michael Carrick is doing, I do hope and pray and believe that tomorrow will be better for Manchester United. I sincerely do. But I'm not like really following them this season. I just want to see how things go before I'll decide. But for now, I'm a neutral of football and I just want to enjoy myself. Life is hard. I don't want to make it harder by supporting clubs that they don't pay me to watch football, right? So So that's the fun fact. That's the light note. On a serious note, one fun fact about me is I love eating, right? I love eating so much. So before the call, I was telling Nosy, at some point in time, say 5, 10 years ago, no matter how much I eat, I never get satisfied. I was eating so much and I didn't have much that time. But now I eat once a day and my seems like my tummy is getting big and I'm like, okay. So I've seen people in their 40s, 50s struggle with big tummy, and they tell me that they should have done something about it. So I don't want to be that. So, I just eat a little, then you have to do these exercises. you do the pumping thing and you do the sit up and you do like this just to get to flat tummy. So it's not easy, man. It's not easy. But yeah, I want to keep fit, want to look fit and keep fit and live healthy. Yeah. So that's basically it about me. I'll be hosting the session. I want you to come prepared. I wish it was that easy, nosy, eat and do sit up, but yeah, we'll keep pushing. We keep pushing. Yeah, we'll keep pushing. Yeah, so the learning outcome for today is very simple, straightforward. We want you to be confidently attempt the Gaussian mixed model and geospatial data, the MCQ, right? So it's important you understand the concepts behind these machine learning models we're talking about. We know that we have AI right now that can solve all the problems, right? But it is very important for someone who wants to build a career in data, in the field of data, or in the data profession, whether you end up venturing into analysis, machine learning, AI engineer, whatever, you need to understand the concept. So I usually start by saying that for those of you who know the samurai, those Japanese guy that use swords, they used to wear this baggy short, is it baggy trousers or whatever? It's like skirts, but his trouser is very baggy. So they use this samurai sword. So they have the samurai code, and the samurai code says the advanced techniques are the basics mastered, right? So there's a temptation right now for you to join data and you want to jump to AI, LLMs, building large language model. It's dangerous because you don't have a foundation. Just imagine building a house and you want to start from the roof, all right? And you just want to rush the foundations and the walls, the lintel, and just get to the roofing because you just saw this very wonderful model for building roofs and you just want to enjoy the beauty of modern roofs. The house will fall, the roof will fall. So the basics are very important. So if you are here, you're still struggling with Python, you're still struggling with the basic of machine learning, the mathematics behind the concept, and you feel discouraged and you just feel tempted to, skip to the machine learning model part, please resist that temptation, right? Follow the basics, go down the steps, understand the core concept. Once you grasp the core concept, building up on it, whatever technology comes, the foundations will remain the same, right? Once you understand and solidify the foundations, whatever technology changes over time, as you begin to build on your career and the concept, is going to make sense, right? I hope that makes sense. So the pattern we'll use today, I do hope that you've looked at the content on Athena. I'm not going to be going through the theoretical part. I'm just going to look at application of this Gaussian mixed model, right? Good. So this is the notebook. We have a notebook. I'm going to open the notebook. So let me copy the link to the notebook. I'm going to paste the link to the notebook here. Live session, Gaussian mixed model, and notebook. Yeah, so let me see if I put it in the chat. All right, so I've put it in the chat. You just get the notebook. And so if you have the notebook, just come to this file and you can download it as .py, sorry, .ipnb. You can come here and download the notebook if you want to run it from your local machine. But if you want to run it on Google Colab, just click on Save to Drive. You create a copy on your drive and you would run the notebook. So I'll connect my notebook and we'll get into it. Please, if you have any question, feel free to drop it in the chat or ask in the chat. No, not in the chat, in the Q&A. I'll be keeping tracks. And yeah, let's go. So today we'll be looking at geospatial, Gaussian, not geospatial, Gaussian mixed model and geospatial data, right? Can anybody tell me what geospatial is from off the top of your head? What do you understand by the word geospatial in the chat, please? Please let's make it a bit interactive, right? A bit interactive. I'll need you guys to help me respond in the chat so that I don't feel like I'm talking to myself. Good. So geo means earth, right? Why spatial means space. So geospatial data, so data that has to do with the earth and space. So data that has to do with like location on the earth. So that's what geospatial data is all about. And we're going to have a look at it. As I said, I'm having this session on the assumption that you have looked at the content on Athena. I don't want to start repeating what's Athena on Athena. We just want to have a live demo and see how we can apply this concept, right? Good. So the learning objective is by the end of this session and notebook, you should be able to confidently attempt the Gaussian mixed models and geospatial data MCQ. So you can use AI for the MCQ, right? And don't even stress yourself. I would advise against that. I would advise use your brains and use AI to cross-check. We are in a very critical moment in life, right? Before the advent of AI, a lot of us were thinking, especially programmers, those in the tech space, and every other person. We are spending so much time thinking. We're using our brain power to think. Right now, it feels like AI is taking that from all because, I mean, you don't have to stress yourself. You just feed everything to the AI and it gives you. It's cool, but on the long run, it has its disadvantages. So I usually advise before you feed it to AI, think it through, right? So if you have this assessment, answer the questions, probably don't submit because you to get high score, you only have one chance to get your highest score above 50, right? So I advise to use your brain, but just use AI to cross-check your answers so that you give your brain opportunity to think, right? So after this session, based on what we'll cover in this session, you should be confident enough to go through this MCQ and answer it even without looking at AI. All right, good. So I like putting one thing about tech is you don't just learn, you have to find how you apply what you have learned. Does that make sense? You don't just learn theory. Theory is good. When you get the theory, one of the ways to solidify that theory or that concept you have learned is to practice with it. And by practicing, I don't mean practicing for the sake of practice. Just try to use it to solve a problem, even if it's like a simulated problem. Just try to look at it at how can I use this concept to apply to real world. That way you remember the concept much more than just reading your notes, okay? Alex says there's a lot of AI training this year. The situations about thinking will become worse next year. Exactly, exactly. Exactly. So those in this generation, those who aren't there when people are using their brain to think are at a massive disadvantage. So right now, it feels like those that know how to use AI, like you can use AI to do everything, right? In the next 5 years, we'll be missing something important, those that know how to think, because everybody relies on AI. Then those that are using their brain to think will have an advantage over those that just know how to use AI. So for me, everything is about balance, right? Use AI moderately and make sure you give yourself opportunity to exercise your brain power. All right, good. So we're going to look at the scenario. I hope you can see the screen. If it's too small, let me know and I can zoom in, right? Good. So what is our scenario? Remember, as a data professional, your primary goal is not to learn Python, is not to use Google Sheets, is not to use MySQL or Power BI. Your primary goal is to solve problems using data. And how do you solve problems using data? You solve those problems using data by looking at the patterns in the data. So you have a raw data, you arrange the data, you clean the data, you put the data in format that it's clean and process it. Then you look at the pattern, you identify the patterns in the data. Based on your findings, you can now make informed decisions, all right, or data-driven decisions. So you can give stakeholders solid decisions, not based on assumption, not based on emotions, but based on facts found in data, right? The truths found in data. So for today, we'll be using this scenario, right? You are a city planner analyzing urban development patterns, right? So as we have said over and over, a concept of machine learning or data can be applied to any field as long as there is data in that field, and there is data in every field. So technically speaking, as a data professional with the skills we have learned from this program, you can work in any industries as long as you are providing solutions to their problems, right? So for this session, we are simulating the scenario. We are working as data professionals that work with city planner, analyzing urban development pattern. So you want to segment different regions of a city based on economic activity, population density, commute times, and unemployment rates using Gaussian mixed model. Additionally, you use geospatial analysis to map and interpret data. Good. So we're trying to cover two things at once. We'll see how far we can go. Wherever we stop, I'll give you the notebook. The notebook, we have the notebook complete from top to bottom. It's all here, and we'll be giving it to you. Good. No, I don't want my inputs. How do I remove clear all outputs? Yes. Yes, good. So when you have first challenge with the problem, the first thing you do as a data professional is you don't write code. You don't jump on the data. You try to understand the problem. All right. So I'm going to read this line again and I'm going to ask you a question. Please listen attentively. Look at our scenario. You are a city planner analyzing urban development patterns. You want to segment different regions of a city based on economic activities, population density, commute times, urban unemployment rates using Gaussian mixed model. All right, let's forget about this additional. So you want to analyze the urban city. Now, in your own words, I would like in one sentence, what problem are we trying to solve in this scenario as a city planner analyzing urban development pattern? Anybody in the chat? Based on what you see here, let me highlight this text. Based on this text, what problem do you think you're trying to solve? What will you do that will say you have successfully solved a problem? What solution are you trying to bring? So let's start. What problem are we trying to solve here? Or what do you think that's a problem here for us as data professionals to solve using Gaussian mixed model? Anybody in the chat? Anybody? Abdul Rahman say population control. Good. Good. Any other person? We are trying to you are a city planner analyzing urban development pattern. What do you want to achieve with this analysis, analyzing the pattern in the urban development data? Abdul Rahman say population control. There are lots of us in this call. Or don't we understand the question? Okay, ALX says, how all the factors influence city planning. Good, good. BM, sorry, I can't pronounce your name. I'll just call your initial. BM says, economic development considering population. Good, good. Can I get two more before I move on? Two more. Minimizing traffic. Good. Vera says, helping the city figure out solutions to the challenges it faces using the provided data like traffic when it comes to commute times. Good. Good. Now, the first thing, always remember, when you are faced with any data problem, don't even jump to the data. I want you to look at the problem. So some of us, we are so tempted to write code that we jump at solution. In fact, I've experienced people that they solved a problem and they created a solution using data science, machine learning, and all that. And you ask them a question, what problem did you solve? And they can't really articulate the problem. So if you are doing this, for every solution you are providing, sit down and ask, what is the problem? Okay, let me joke a bit, all right? That's why sometimes in relationship, you see one partner is doing so much and the other doesn't appreciate. Not that the other person is bad, it's not that the solution being provided is not solving the problem. Okay, let me bring it to football. There are some football clubs that just buy players. Okay, Nozi say resource allocation problem. Good, good. So a football club, you don't just buy players for the sake of buying players. Before you buy a player, you look at your squad or your team and ask yourself, what do I need before I go to buy? Okay, let me bring it home. I love cooking, right? If you want to go to the grocery store, Eric, I didn't mention any club. I'm just saying, but you understand, right? That club just buy players. They don't look at their squad to figure out what the problem is to buy players, right? So similarly, if you want to go and restock at the end of the month, let's say you just got some money or you collected your salary or you won a lottery or something, but you got money into your hand. Before you go to the market to buy, the wise thing to do is to look at your house and ask yourself, what do I need? What are the things that I need? What is going into it? Is there milk at home? Is there oil? Is there what kind of groceries are lacking? Then you find those things and buy. So you don't start from the solution to the problem, you work from the problem to the solutions. And first of all, I would say thank you everyone who contributed to the problem we're trying to solve. All right, good. Now I'll read it again. Okay, let me say this again. The solution you are trying to find for the problem becomes easier to find when you really understand the problem. Some of us, and I want you to apply all these things into your personal life. Data is real. Data analysis is real. Data science is real. Machine learning is real. It's not abstract like what we did in school. Some of those courses we did in school, right? That you can't really see the practical application. In data, you can see the live practical application, right? And that's what we want to achieve today. So we said, and again, yeah, good. That reminds me. When you are solving a problem, like can anybody just put a course you study? Like what were you? I mean, what do you study, right? Anybody? I want to use somebody for an example. The first person that put their career outside of data. Okay, good. Mubarak Lawal. Are we brothers? Are we brothers from different mothers? Okay, cool. Mubarak Lawal says he's an economist, right? Now that you are venturing into the data, right? You're no longer economics, you are a data professional, but that economics is an advantage. Why did I say that? When you are working on medical or health problems, you are assuming the role of a health professional because you have to step into the role to understand how to solve the problem. And that's why when we talk about solving data problems, that's what we call subject matter experts. In your career as data professionals, you're going to shuffle different problems in different areas. For example, this problem we're solving, I am not, I think people who study environmental science, people who study geography and planning, people who study, there are courses that are related to this, right? Now, we may not have the subject matter expert, but because we are data professional, we have to go in and study city planning. So we are assuming different roles. So if you are solving a health problem, for example, during coronavirus, we have to shift our mind to start thinking like health professionals. If we are solving a financial problem, we have to shift our mind to not just think as data professional, but to put ourselves in that situation to think like a banker or a financial personnel or something like that. So depending on the problem you're trying to solve, and that's why when you decided to jump into this data career, you have decided you signed an invisible agreement with lifelong learning. If you think that at some point you stop learning and just be making money, that's not the truth. You keep on learning, right? So we are now assuming a role as a city planner, right? So that we get the subject matter expertise required to solve the problem. So you will come to a moment in time where you have the data skills, but you don't have the subject matter expert, which means you either have to go and learn and read it or have an advisor who's a subject matter expert to guide you for some technical terms, right? Good. Now we have started solving the problems, right? But we have not written any code yet. That's how you solve data problems. You don't jump to use the tool, okay? You are not limited by your tool. There is more to you than the tool, okay? So let me ask you a question before we continue. Sorry, I watch a lot of movies and I watch superhero movies. Now, let me ask you, off the top of your head, if Batman and Iron Man fights, who will win? Honesty. They are fully kitted in their outfit. Batman wear his cape and the whole black stuff. Iron Man wear his you know what Iron Man wear, right? He put the iron suit. If they fight, who will win? Be honest, right? Who do you think will win? Anybody in the chat? Iron Man, good. Why? Iron Man have a sophisticated, exactly why. So Iron Man have a sophisticated outfit, right? So he would definitely win Batman. Now, we know that the man inside the iron suit is called Tony Stark, and the man inside the bat cape is called Bruce Wayne. So if we take off the suit of these individuals, okay, Adebowale say he needs the link to the notebook. Okay, yes, Adebowale, I've put the link. So if Tony Stark steps out of his iron suit, and what's his name? Bruce Wayne stepped out of his cape. Now they go hand-to-hand combat, Bruce Wayne and Tony Stark. Who will win? Who do you think will win? If you know the story of Bruce Wayne and Iron Man. Exactly. Exactly. Bruce Wayne will win. Why? Because Bruce Wayne is a trained martial, what do they call them? Martial artist. Yes, good. Bruce Wayne is trained. So Bruce Wayne is stronger. All right. Exactly. Thank you. Thank you. So you are not defined as a data professional. You are not defined by the tool you use. You are defined by how you think. So they can give you Google Sheets, you will solve this problem with Google Sheet. They can give you MySQL, you will solve the problem. They can give you Python, you will solve the problem. They can give you Power BI, Postgres. The tools will be could change, but the person behind the tools, right, is what determines how to solve the problem. So don't just focus on learning tools, focus on problem solving. That's why the first course we did back in Explore 101, if you remember, when we're doing the problem solving, pseudocode, flowchart, we are teaching you how to solve the problem, having the mind of a problem solver, right? So don't just memorize tools, right? Tools will change over time. There was a point in time when, what was used, Seth? I think it was R programming language that was used. Now Python coming, we don't know. Maybe Cobra in the future will be the next big thing. But tools will change, but your thinking of solving problems will remain the same. Okay, good. So let's get back. You are a city planner analyzing urban development. You want to segment different regions of a city based on economic activity, population density, commute times, and unemployment rates. So look at this. The data set overview, as I said, before you jump to the data, you need to understand it, right? Understand what's happening. So the data set represents 300 city regions. So we have 300 data points, right? With geospatial and socioeconomic data. Column explanation. So we have 9 columns. Region ID, unique identifier for each region. Longitude and latitude, I think, yeah, there are 2 different columns. Population density, commute time, unemployment rates, median income, business activity score, land use, crime rate. If I'm going to ask you, which of these columns will be most important in solving this problem? Off the top of your head, we have not even written any code. We just want to use our mind to see if we can think. Anybody, of all these columns, you know, we talk about the problems we want to solve, right? Urban planning. Which of them do you think will be most important in solving the problem? Off the top of your head, there's no wrong or right answer. Okay? Abdulrahman says population density. Okay? All right. The next person say population. Okay, fine. Number of people per square kilometer. Good. So you see, we are already crafting a solution without even writing a single code, right? So we want to know how to plan the city. All right. What do we mean by planning city? What do we mean? When someone say, I want to plan my city, or let's say a governor said, I want to plan my city, or a president say, I want to plan my city, or a, what do you call the people that lead the city? Is it local government chairman or a government office of how will I put it now? A government official in his district or region or county. When he say, I want to plan my city, what does he mean? Okay, good. Make the city conducive. Okay, Mubarak Lawa say longitude and latitude. Okay, that's nice. Alex says optimize resources allocation. Good. Good. So this is what we want to achieve with this. How can we plan our city based on this? So some people say the most important feature is population density. Some say it's latitude and longitude. Okay. Yeah. So median income could be it, unemployment rate, business activity score, and all that. So let's just quickly look. Longitude and latitude, of course, we all know from geography, longitude and latitude, geographical coordinates for mapping, population density, number of people per square kilometer, commute time, average time in minutes. So commute time means the average time a person needs to go from their house to school, or from their house to work, or from their house to market. That's the average time. That one by average commute time. Unemployment rate, percentage of unemployed people. Okay, so percentage of unemployed people within that region. Median income, that is average income in dollars. Business activity score, score indicating economic activity, which means a higher number of score means higher activity, higher business activity. A lower number of scores means lower business activity. Land use type of land use, residential, commercial. No, I don't think this is part of the data. Then crime rate, normalized crime score between 0 and 1, where higher values indicate higher crime levels. Good. Now, have you noticed that we have not written anything, but we are now having an idea of what we are trying to solve? So remember, as a data professional, you don't jump into the solution. As they say, you don't jump into conclusion. You think into conclusion. You reason into conclusion. You you don't fall in love. You think into love. Is that correct? I'm just kidding. I'm just kidding. All right, cool. So step one, when we now understand, okay, all this we did was step 0, right? Let me put it like this so that it makes sense when we get the data. Let me put this. Sorry. No, let me put it. Step 0. Step 0 is understand the problem. Good. Step 0 is understand the problem, right? Now we've have a good understanding of what the problem. Want to get it. Okay, Mubarak Lawa said, I say longitude and longitude because they are what make the analysis geospatial. Without coordinates, we can't map or interpret the patterns across the city, which is the whole point of the task. Exactly. Good, good, good. So I do believe everybody have a reason for saying the column that they use for the solution. All right, good. So we now import necessary data, right? So I'm not going to really go into all these. I know I've done a lot of importation, but I added what do you call this thing? Comments for you to understand what each import is doing. Okay, so I'll just go straight to run the code, run anyway. Good. So for learning purpose, we're not using live data, but for learning purpose, we are using generated data. Okay, so we are using simulated data to solve this problem. Good. So we'll run this code to generate all the data we need. Okay, good. Then we would convert it to a data frame, and because we just have the NumPy arrays of this data, we want to put it into a data frame. Okay, so this code put into a data frame, and we will display the first few rows of the data so we can run the code. Good. So here are the columns we have: latitude, longitude, population density. That's what do we call population density? Number of people per square kilometer. Good. Population density, crime rate. So which means in this region, the crime rate is high, 0.82. This region, the crime rate is low. This region, the crime rate is high. This region, the crime rate is low. Okay? And you can see income level. You can see time to commute in minutes. You can see unemployment rate, right? That's 8%, 10%, 6%. I want you to look at something before we move on. Or should I say this? 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 Okay, let me say this. Let's say there are 5 of these cities, right? 0, 1, 2, 3, 4. All right. Each line is a region in the city. Now, with this data, so we have region 0, region 1, region 2, region 3, region 4. Let's say you come to this town or this country and you want to establish a business. Can you, off the top of your head, use this data to determine which of the regions you will establish your business? Anybody? Region 0, region 1, region 2, region 3, region 4. I want you to look careful. Look at the latitude. We don't really need this latitude and longitude. Look at the population density, the number of people per square meter in that region. Look at the crime rates in percentage. This is 82%. Look at the income levels. Average, what's income levels? Income levels. Okay, we didn't put income levels. So this is the amount of money they make, commute time, and unemployment rate. So everybody is saying region 4. Why region 4? Okay. So I believe region 4 has big population. Crime rate is 39%. Okay. Income level 67,000. On average, they have money. Commute time 55. Okay, not good. Unemployment rate 10%. Okay. So you see, it makes sense why you chose region 4, right? KD said 3 makes business sense. Let me see region 3. Population density. Okay, a bit less than region 4. Crime rates way lower than region 4. So region 4 has 39% crime rate, and region 4 have like 12% crime rate. Okay. Income level 52,067. Okay. Commute time. All right. So KD say he rather go for a city that is a bit less but lower crime rate. Okay. So I want you to see how we are already starting to make decisions. We have not even started solving the problem. We're just a glance at the data. We can now start making sense, right? But KD, I hope you know that 21% of the people are unemployed, right? So there are 21% minus 9, that's just 79% of the people that can pay you, right? Good. So these are the things. You take the pros and cons and decide, okay, what do I want to make and all that. Good. Nosy said region 2. What does region 2 have? Okay. What's the crime rate? Oh, crime rate is really high. Abdulrahman say region 2 is dangerous. Yeah, I don't know what is making crime rate high because unemployment is low. So I don't know why people are. So you can see we are now already making inference, right? Now, this is how machine learning model finds patterns in data, right? We know we're not doing the data modeling, right? The machine is doing the modeling or the machine learning model, but it's good to have an idea of, as they call it, the black box behind the hood, what is happening behind, right? So we have a glance of our data. So we have 1, 2, 3, 4, 5, 6, 7 columns. Good. Now, we want to convert it to GeoPandas data frame, all right? So this let me see something. Data. Can I do dot type? If I do type, let me see. Type, will it give me an error? Oh, to give me. Okay, good. You see, it's a pandas core data frame, right? This is a pandas core. Okay, so we can delete it. We want it to be a Geo data frame. So this is a typical data frame, but Geo data frame makes it a data frame that have location, right? And to find the location, we need longitude and latitude, right? So we would use we want to zip. Remember, this is what do you call that thing? This lists something. Oh my God. Somebody help me in the chat. What's this thing? It lists something, no? Instead of using for something. Hey, instead of using loop. God, somebody is list something. Somebody help me with the name. List comprehension. Thank you. So we do forget this thing sometimes. So this list comprehension, right? Instead of using for loop, we just want to zip, want to put this longitude and latitude together. So this longitude and latitude help us to get your location. So if I know your longitude and latitude, I can pinpoint your location. So we'll use it for this geometric data, for this geodata frame. So what we're trying to do is to put the longitude and latitude together. So I'm going to run this and you can see. So you can see the longitude, latitude 6, and longitude 6.6, longitude 3.2. So 3.2, so you can see 3.2 and 6.6. Good. So we have put it in the geometry, right? I want you to watch something. If I put the data, okay? I put the data. Let me put crime rate. Yet you see something. So if I put what is it? Is it crime? Crime rate. And I put type. Okay, no, .d type. .d type. I think you should give me. Yes, good. You can see this D type is float. All right, this D type in float. If I put population density, that's the type of data in that column. You know, columns take data of the same type. You can see it is in 64. Now, if I put geometry, now I'm going to ask this question. What will be the data type be? Anybody in the chat? If I run this code, what data type will be this column? This is how we created it here. What data type will be the column? Anybody? Anybody in the chat? Come on, somebody. Guess. What data type will this geometry column be? Remember, we just combine this latitude and longitude and see how we combine it. We say point, latitude and longitude. So point, longitude, and latitude. What data type would this be? Geometry. Anybody? Come on. Okay, Mubarak said geometry, maybe. Okay. Anybody else? Do we agree with him? Yes, if we agree with him. No, if we do not agree with him. Do you guys understand my question? Okay, somebody say object, string. Okay, good. All right, so we have 3 answers: geometry, object, and string. So let me run the code and drum rolls. O means object. So this is an object. It's actually a string, right? But it's also called an object. It can be classified. So it's an object because we just merged these two. You can see this point. This is a text. So it's an object, which is like a string, right? So it's an object. Good. So we need, why we use this point, because we need it to create the geometric data. So it's not yet, who put geometry? Mubarak, it's not yet geometric type, right? So we just put a ticket. So what we did was we zipped the data longitude and data latitude, pair longitude and latitude value together, convert each conjugate into a pair, into a point geometry, right? Store these points in a new column called data frame. Good. Now what we want to do, we want to now convert it to a geometric data. I remember when we're importing, see what we did here. We import what? GeoPandas. So GeoPandas is a geospatial data handling and mapping. So this is what we use to find the mapping on the map. Yes, the location. So this is the code. We'll now get gd geopandas.geodataframe.data. So we take this data frame, this whole data frame, and we are just looking at the geometry. Does this column, all right? It says convert this column to a geometric data. So we now run it and we'll see. Good. Look at the data. You can see it's cleaner than this one. Okay. Now, if we come to run this thing again, okay, it's no longer data. It is now Where is it? It is now GeoDF. So if we run it, and you can see it is now GeoPandas. So this is the geometric data. Good. Now we now have our GeoPandas. Good. I'm now ready to get into our analysis, all right, or our clustering. Okay. So remember, unsupervised learning, unlike supervised learning, that's regression and classification, we have what's the difference between supervised and unsupervised? Supervised, there is no label, right? No, unsupervised, there is no label. Supervised, there is label. So you have the future and the target. You have the future variable, we have the target variable, and we try to predict the target variable. But in unsupervised learning, we don't have any future. We just have features. We don't have target variable. So what we try to do is to group the data, and there are many techniques to use to group the data. Why Gaussian mixed model is one of them, right? Good. So before we do the applied Gaussian mixed model, is there any issue with our data? Anybody? Do you think there's an issue if we try to supervise the cost target variable? Is our data in good condition? Do you think there's any issue with the data? Can we go ahead and fit in the data, the geomodel, a geospatial mixed model on the data? Yes, no, just have a look at the data. Don't worry, they are not missing values. It's synthetic data, so they are not missing values. Off the top of your head, from what you have learned, is the data okay? Is everything cool? Can we go ahead? Exactly. You can see we have 6.6, 3.2, 104, 0.82, 52,089. So there are different scales. So we can run it, but it will affect the clustering when the model is trying to cluster the data, right? So what? Step 5, applying Gaussian mixed model. First of all, we do future scaling. Now, remember, in unsupervised learning, we split data into train and test because we're trying to predict. You don't do that for geospatial data. You just fit your whole data. You don't do training and testing, right? Good. You don't have to do X train, Y train, just fit your data. Good. So we have scaled our data. So you can look at what the data look like this. This first row, look at it. It's now 0 points. They are all scaled. Good. Now the next thing is we initiate GMM with 3 clusters, right? I believe you must have learned how to know the number of clusters, right? We'll not go delve into deep. I think Mbali covered it. The one you are using that elbow something. What do they call it? I've forgotten the name. Something about elbow. You try to find the best. You plot. There's something you will plot to try to find elbow method. Thank you. Elbow method. So you try to find the best number of the appropriate, not the best. There is no best in quote. There is just appropriate. And also it also depends on the what you're trying to solve, right? That's why I say understanding the problem will help you understand. So based on the problems and the elbow method, you use different parameters to discover a number of clustering, but we're just using 3 for default for simplicity. Okay, good. So Gaussian mixed model and number of components, 3 clusters. So we're using random state of 42 for reproducibility. All right, it's very important, but it's not necessary, but it's important for learning. So we have this, and okay, okay, good. You know that things are improving, right? So we have this model, and see something important. The model not fitted. That means the model has not yet been fitted to a data, right? Good. So we have our data. This is the scale data. Now we want to fit our Gaussian mix model. So we do gm.fixPredict, and we run it. Okay, we fixed and predicted. Okay, so what this fix predict means is fit the model to the data, try to cluster the data, and look at the clustering, the group of clustering. So remember, we said there are what do you call it? 3 components, right? So it will be cluster 0, cluster 1, cluster 2. So it have looked at all the data points and it have created the clustering, right? So we'll now add this clustering to our data. That's this data. We'll add the clustering to our data. So we'll say cluster fit model. Good. So we have cluster. So this region, it has been classified into cluster 2. This region has been classified into cluster 1. This region has been classified into cluster 0. Okay? Now I'm going to visualize the data. Now remember, when you are learning, if you remember some of the clusters that Mbali used last week, because it's learning, the clusters were finally grouped into different places. I have them, you will see them later on this slide, on this notebook. Because for learning purpose, we want to make it clear, we'll put the clusters together, very defined. But in real world, things will not be that clear. You understand, right? So that's what we're going to experience right now. So we're going to visualize our data, and we want to visualize this data. We can't visualize everything. Remember, the human eye cannot see beyond the 3 dimensions, right? And we have 1, 2, 3, 4, 5, 6, 7, 8 possible dimensions. So we'll just use 2 dimensions to cluster the data. Okay. So if you can see we are using the income level and Y label. When you get the notebook, play around with this X and Y. Compare 2 variables. You can compare population density and crime rate, population density and income level, population density and commute time, Okay. Give me a second. Let me see if I can do something. Let me try something. Give me a second. Mm. Mm. All right, good. Sorry about that. So we're going to visualize. We're just looking at the income levels and crime rates. All right, good. Now, is it clustered properly? No. Right? No, because this is how real data works. So we have 3 clusters. Cluster 0, cluster 1, cluster 2. Now, is the cluster really clear? I want your response in the chat. Can you say the clustering is like clear? Anybody in the chat? Can you say good? Good. The clustering is not clear, right? But I want you to look deeper. As a data professional, you don't just look things as surface level. You try to look deeper, right? So I want you to look at the colors. Now it's scattered. You are expecting to see one side gather here, one side gather here, very clean, right? You didn't see it. Then you now look deeper, okay? Look deeper. Can you see clustering now? Look beyond I know you just look at the dots, and we just say, oh, there is no pattern. I want you to look deeper. Anybody on the call, can you see a pattern? Can you see clustering, no matter how small? I want you to look. Can you see it? Good. Now you can see the blue. The blue are clustered around here. To the right, exactly. You can see the red. The red are clustered to the left. Then the whites are just scattered. This is the real world scenario. You will not see any data that will give you everything clean. So what do you, okay, let's start by, what can you infer about the blue cluster? The X label is income level. This one is crime rate. What can you see about these blue clusters? Anybody? What can you infer? So this looks like people in high region, see their income, 20,000, 30,000, 40,000, 50,000, This is the first point of blue. That is around 58,000 thereabouts. The more income, the more the crime rate. Exactly. So you can see crime rate started around here. You can see the income moved and crime rates started in the rich region. Crime started from zero everywhere. You can have crime rate because you can see these are the rich people here. The red starts. The red covers from here down here. I think the highest earning in the red is about 62,000, 61,000. So this guy, this region, they are the big boys of these other people, right? They earn more than every other person, right? And this guy is supposed to be in the red cluster, but he somehow find his way into the rich region, right? Then the whites, what do we call about the white? They're just everywhere. So even in the scatteredness, we could still see some pattern, right? That's the eye of a data professional. You look beyond what people see. Does that make sense? So I would appreciate if in your leisure time, play around with this, try other variables, right? Let me see. Give me a second. Okay. Let me just get this code. Let me see if it will work. This was not part of the class, but let me just see it. Should I leave the code? Okay, let me have this code and let me see if it will work. Okay. All right, good. So let's see something. This is not part of the class, but I just felt like it's important we see it. All right, good, good. I just added the code, right? So in your leisure, look at this thing. This is not part of the class, right? But just look at, we can see different variations of things happening. Okay, we can look at crime rate and income level, the one we had. We have income level and unemployment, commute time and income level, population density and crime rate, population density and unemployment. And yeah, we have all that. Good. So when you have this notebook, just look at it and start making your inferences, right? Start drawing your inferences based on what you see about the data, what you can conclude. Good. So these are our main data, right? Income level and crime rates. Good. Now we'll go to the next thing, which is how do I put it now? So you may not be, don't bother yourself about these big terms, but just try to understand the concept, right? So there's what we call expectation maximization algorithm in GMM. I want to say this now, right? Please, whatever background you come from, whether you came from business background, accounting background, once you join data, you're now a scientist. I want you to know. So don't say, I don't come from a technical background. You are now a technical person. I don't like hearing when data people come and say, oh, I don't come from a technical background. Once you go to America, you're an American, in quotes, right? Once you go to Rome, you are a Roman. So once you come to data profession, you are a data professional. Your background doesn't really count on how successful you will be. Okay? All you need to do is to work hard. So once you see concept you don't know, please go the extra mile to study. You are a researcher, you are a scientist, you are someone that craves for knowledge and understanding of concept, because those in the data professionals are seen highly. Have you ever gone to a place and you introduce yourself, you just say, I'm a data professional or I'm a data analyst? The way they look at you is like someone who fell from the sky, because we all know where data is going in the world right now, right? So if you're on the call listening to me, don't use words like, oh, I don't come from a science background, I don't come from a data background, I come from whatever you study. And the truth of the matter is that whatever you learned previously can be applicable in this field, because this field is an interdisciplinary field where you can transfer all your knowledge, whether you're coming from literature background, you are coming from agricultural background, you're coming from accounting background, you're coming from journalism, whatever background you are coming from. In fact, if you are coming from no background, whatever you have been through in life can be applied. The skills can be transferred here. Okay, so the expectation maxima algorithm, right, is the key optimization method behind Gaussian mixed model, right? It iteratively refines clustering assignment by estimating probabilities of data points belonging to different Gaussian distribution. So it helps to find the mean. So every cluster has a mean. If you remember, yeah, what was her name? Mbali talked about it last week. Every cluster have a mean, and there's this process that it goes. I think it was explaining the content, how it finds the mean of the clustering, right? So this is the code we shall use to find the mean of the clustering for each column, right? Good. So look at the means. So look at this table. So remember, we have 3 clustering, right? For the population, for the group 1, the average population is 0.053. For group 2, the average population, the mean population is 0.3. For group 3, for group 2 is 0.17. So before we group the data, please follow me. Please follow me. Before we group the data into cluster 1, cluster 2, cluster, we found the population density mean of all the regions, right? So 0.05. So of these 3 data, of these 3 regions, it means region 2 have the highest population mean. So of the population mean of the whole data, region 2 has the higher population mean because it's 0.1. While region 1 has the lower population mean, while region 0 has the what? An average. So when it comes to the mean, region 2 has a higher mean than the other 2 regions. So region 2 has more population. Does that make sense? Do we understand? All right. Okay, good. I will come to crime rate. Now, before we, remember when you run your model, for those of you who have experience, when you run your model and your model is running, is taking time, it's doing calculations. It's all this calculation it does on the back end, right? You can actually do machine learning on paper, but paper have a limit. You can be doing this calculation, but it has a limit. How many of you have used this old calculator? What they call it? I think it's is it Casio? There's this old calculator. I don't know how to describe it. It's not it's scientific. Yeah, exactly, Casio. When you do some calculations, it will now tell you error. Now that error, it doesn't mean that what you calculated is wrong. It means that you have exceeded the computing power of the device. So it says error, right? So if I ask you 1 plus 1, what do you say in the chat? 1 plus 1. Anybody? Come on, man. We're smart. 2. 2 plus 2. 4. 4 plus 1.3.5. Something like that, okay? So it will, it will take a while. So that's how it is. The computing, who is this person? Abdul Rahman. Okay, thanks for that. So, what was I saying? Okay, good. So all this computing can be done on paper, but they have their limits. So when you are running a model and you hear things like my computer crashed when running the model, it means the computing power of the calculation have exceeded the size of the computing have exceeded the computing power of your system, right? So there are times you are given a food to eat, you have eaten the food. So the capacity of your bowels, your stomach, is more than the food. Then when you get to time when you have eaten and you can't eat no more, it means the food is more than the capacity of your bowel, right? So that's what happens. So a lot of calculations is going on in the background. So for this crime rate, what it will do, it will now first of all find the overall crime rate, the average crime rate of everything, right? Of the data for the whole data. Then to now find the individual crime rates. So of the 3 regions, which of them have the most crime rates, the highest crime rate of the 3 clustered regions? The 3 clustering that it was clustered. Anybody? Look at the data very well. Which one has the high crime rate? Region 1, region 2, region 0, region 1, or region 2? Which one has the highest crime rate, higher crime rate? Good, region 0 has higher crime rate. All right. While region 1 has a lower crime. So it is negative because it is lower than the total average of the data. Right. So if I want to live in this city, one of the things that will influence my city is crime rate. If I want to live, I would rather be in this region too, right? Region 1, cluster 1, sorry. Now, if you notice, I have 3 numbers highlighted in black. Why? Of all these averages in the data, these ones had the highest. Remember, I asked you a question in the beginning. I said, which of these columns have the higher determinant of the clustering of this problem we're trying to solve? Some people say population density, some people say commute time, some people say latitude and latitude. We're doing it off the top of our head. Remember, as a data professional, there is no truth or wrong. We just have inferences, right? What do you call that thing? Hypothesis, right? We don't use true or false or right or wrong in data. We just use hypothesis. And we don't say if this hypothesis turns out to be true, we don't say it is true. We just say hypothesis accepted. Because this hypothesis could be rejected, could be false tomorrow. So instead of saying this is truth, this is false, we just use hypothesis and hypothesis accepted or hypothesis rejected. So, for example, if I'm looking at this off my top of my head and I say, I think that population density is the determining most important column to determine the solution of this problem. It's not truth, it's not false, it's just hypothesis. And this is the hypothesis. Then we will now run our analysis to see that if we accept or reject this hypothesis. Let's go back here. Where is this clustering? Good. Now, if we look at it, based on the average, you see income, this one has this high income. Which of the columns would you say have a more determining factor in the clustering of this data or in solving our problems based on the data? Commute time. Okay, somebody say commute time. Good. Okay, and then you can argue to be income level, right? Exactly, because commute time we have 3 of the highest values or the averages. Commute time has 2 and income level have 1, which is the highest. So to balance it, we will say the 2 important columns is income level and commute time. All right. So it's not as if crime rates are not important. For example, if you look at the income level, you want to start a business. You know that this cluster 0, they have money. These guys are rich. They are the high-end people. So, you take your business there. So let's look at the interpretation. Cluster 0, it has the highest income level and moderate commute time. You can see the commute time is 0.2. It's not too bad. The average is 0. The average of everything is 0. So it's either greater than 0 or less than 0. The commute time is not too bad. So high income, average commute time. Then the cluster 1 has what? Short commute time. The commute time is very less, lower than the average commute time of the data, but lower income. You can see the income is low. All right. Then cluster 2 has, what do you call it? Lower income level, but longer commute time. All right. Now, let me ask a few questions before we continue. If you want to build a luxury hotel, in which of the clusters will you build that luxury hotel? If you want to build a luxury hotel, good, because you want people to be able to pay. If you want to build an affordable accommodation, something like students can afford, which of the clusters will you build it? You want to build an affordable accommodation for, say, students. Which of the clusters? Okay, good. Okay, one last one. You want to build a bet center, like Bet 360, where people will come and be betting. Where do you think that business will flourish? Cluster 0, Abdulrahman, do rich people bet? Yeah, rich people bet. But if you want to build a bet center, okay, Abdulrahman says cluster 0. Okay, fine. Yeah, I believe you have a reason. NN says cluster 2. Eric says cluster 2. Okay, Abdulrahman, I would like to know your reason why you put a bet center in cluster 0 where there are high incomes. You want people to put high stake, like big millions, so that you make that money well, right? But I mean, could be 2 because of let me see the unemployment rate. Ah, okay. Abdulrahman. Okay, so Abdulrahman, as a business person, would you want one customer that gives you one big amount of money? Okay, let me put it like this. As a business person, I'm asking everybody, will you want to have a business that one customer gives you a high amount of money? Or you want to use the economics of scale where you have thousands of learners who pay you small? One thing I want to know, Abdulrahman, the day the rich man decide not to bet the high stake, you have lost customers, right? So you have to balance. Do I want few customers that are very rich or customers who are not poor, but they are many, right? So you have to do the economic, you have to do the balancing. So these are the decisions you look at when you're trying to plan, okay? So when you are trying to plan the city, these are the metrics you look at to help you plan the city. Remember, we say we're trying, when we talk about city planning, how to improve the city, where do we build where? If you want to build a private university, you know where to build the private university. If you want to build, what can I call? I'm thinking of other things, right? I mean, you with this information, you can know which of the clustering you will put your businesses. If you want to build a house, let me ask you a question. If you want to build a house, let's say you just want to build your house, where would you like to build your house? Anybody? You just want to build your house for yourself and your family, you know. Where we like, which of the clusters we like to build a house? Anybody? I'm expecting something, but let's keep it open. Anybody? Exactly. I mean, who doesn't want to stay in the high end? Exactly. Who doesn't want to stay in the high end? But if you don't have, because, and you know that, okay, let me put it like this. Let's say you just start life, okay? And you came into this country and you saw this data of this region. You know you're just starting life. You don't have everything. Based on this data, this cluster, what we just said, which of the clusters will you be able to afford to live in? Let me use that word. Okay. Oluwa Bukola said cluster 1. Let me see. Okay, the population is less. Okay, crime rate is low, income level is low, commute time is low, unemployment rate is low. Okay, good. You see, now we are making data-informed decision, right? So you discover that it's not only in the data analysis side that you use to make decisions, even in unsupervised learning, we can make decisions like this. So you can use this thing now, go to your city, get the data of your physical location, use this thing, build something with this, and build a project out of this. When we talk about building projects, they are looking for projects that can actually solve real problems. So you can go to your community, you can go to your country, your state, and build a project like this, together something, and it's a unique project because nobody understands the problem you are facing better than you. So this is a unique project. You can take what you have learned, infer analysis, and you can even share the analysis with people and say, this is what I discover about the city I reside in based on the data I've collected. This is what I think how city can build, improve themselves, this, or how the country or how my locality can make improvement, or how I can make better decisions in where to live, where to build my house, where to establish business and all that. Okay. Really, I would like to see what we can do with this, how we can elevate this project. All right, good. And let's go again. So the covariance metric describes how the future varies together with each other, right? So this is like a covariance matrix, how the futures vary together with each other, right? When you begin to compare, right? So when you have this notebook, I want you to try larger clustering. Try cluster of 3, 4, 5, and to see how things will change. Okay. Remember, as a data professional, you are a scientist, and scientists do what? They experiment a lot. Okay. So let's see how we can apply hierarchical clustering to geospatial regions. Okay, so we'll do the hierarchical clustering, have its own clusters. So now we are using income level, unemployment, and we added a hue. Where's the hue? We added what? The hue clustering, right? So the color is the clustering, while the size crime rate. So where is the highest crime rate on this? Where do you say has the highest crime rate? Anybody? It's difficult to see with the naked eye. But where do you think crime rates, where will you live and you see that crime rate is high? Or which area on this graph has higher crime rate? Just try to look at it. It's difficult, but I know. Between 200 to 400. 200 to 400. Okay, good. Good. I can see that there are some big bottles here. Big bubbles. So my question is this: why is a criminal not coming here to this region? Why is a criminal coming here? A criminal will make more money when they come to this region. Why do you think a criminal is staying between 2,000 and 4,000? Why is criminal, or why is there no more crime? Why are there more crimes in this region? Because, I mean, if you want to make big in criminal activities, you go here, right? More assets, but these guys have more money than these guys. But why is crime high here? I want you to think. Why is crime high in low-income areas instead of high-income areas? That's my question. Why do we have higher crime in low-income areas? Exactly, Alex. Probably. Now, remember, in data profession, we don't say this is the absolute answer. We just say this is the highly probable answer. So I got two very nice responses. Alex says low security, because I mean, when you are living in a high house, you have your what they call CCTV cameras, your automatic lock, and all that. And Abdulrahman said they can easily be killed in high income areas. Yes, because of high security. You can see that even the criminal is doing some mathematical calculation in his head before he goes to crime. And let me say this: those that do crime, they are very smart. They are very smart. Just that they're using their smartness in the wrong way, but they are very smart. Oluwabukola says unemployment rate. Yeah, in low areas, their unemployment rate is high, and people tend to, instead of working hard and all that, they tend to resort to illicit activities to make ends meet, right? Now, they are not employed, so they think the solution for them exactly nosy. Now, the whole essence of this is that, can you see how machine learning is being applied to real world problem? It's not abstract. So whenever you are learning machine learning, try to find the connection between the coding, the theory, and how it applies. And that is what makes you employable. Because I know how to use Python. How can you solve a business problem? I know how to use Google Sheets. I know how to use Google Colab. I know how to use SQL. What employers are looking for is all those skills. How can you use it to solve a problem? And that's why they say, what project have you worked on? And the good thing about data profession is that you don't need to be employed to start gaining experience. You can sit down and build a project off the top of your head. Just get data, what do you call it? Advisably real life data. And if I will narrow it down, real applicable data that solves problems. If you can create a project, one or two, very nice project that actually solve the problem. And the good thing about it is that if you work on this project yourself, when you're trying to defend it before employers, it's very easy because you're not cramming. You are speaking from what you have done. So it's easy to answer any question. Now we have worked through this crime project. I can ask you a question about this and you can easily respond, right? Without cracking your brain, because this is not coming from a place of memorization. It's come from a place of experience. You have experienced this solution. You didn't just memorize it. I hope it makes sense. Good. So we have taken it a bit further. to add a third dimension to this graph. That's the bubble chart, right? To see these sizes, to can tell, right? So just by looking, I mean, if I can tell where I want to start up a business, where I want to live with my family, where I want to do things, right? Good. So that's one example, right? Now, you can take this project and do something big about it. Remember, as a data professional, you are solving problems, right? You are trying to use the skills you have and the mindset of a problem solver to solve problems using data. Now, if we go back to the beginning when we had just this data, there's nothing much we could do with this data. But because we have passed it through some processes, we have come to something like this, and we can make some inferred decisions to inform the city planner on, okay, fine, this is how to build your city. In fact, the police can use this. Because if you take this to the police and say, look at the city, look at what we find out, look at where crime is high, look at where we think more police officers or forcemen should be deployed. You understand it, how we can apply it to real world problems. And when you're trying to sell products in this region, you know the kind of products you bring to this region, you know the kind of products, like somebody was saying. I think I could be wrong, but I think that if I want to set up something like a betting is not good, right? But if I want to set up a betting, I think it will thrive more here. Though Abdulrahman said he needs to bring his own betting business here, where high-end rich people will be staking like thousands of dollars. But yeah, unemployed people are trying to win. And so yeah, you can put it anywhere. Good. So I think we have a little, okay, we do have some time. So let's look at another example. All right. So we just import, this is just one example, and let's see another example. Okay, we have imported our data. We have our synthetic data again. Good. We have our Gaussian mixed model. We'll scale our data. We will initialize our Gaussian mixed model on the scaled data. Let's see our data frame. Okay. Clusters. Okay, so this is the clustering. This is a cluster probability. Then let's run our centroids. Okay. The covariance metric describe how features interact with each other. So you can see the covariance. This has to do with something we had here. Okay. The clustering and the probabilities. Good. Where is it? Yeah. Then let's see the covariance metrics type. Okay. Weights. I think I was supposed to visualize. Okay, good. Let's continue. So we have the hard clustering versus soft clustering. I just want to get to something to show you. Okay. Just bear with me. Let me quickly get there. Okay. All right, good. So, this is a synthetic, like actual synthetic data, right? So you can see that the clusterings of the data, because the synthetic data were clustered before, right? This one we did earlier was simulating real life situation where the clusters are not easily clusterable. But yeah, so based on the clustering, it put this cluster in one place, put this other here, and these ones, they're not really clustered, so it put them here. So this is typical example of the Gaussian, what do you call it? Mixed model. Good. This is another example. I'll just run through it. The probabilities. Good. So you can see this is another one, and we're able to put the cluster centering. Yeah, this is just experimented. That's why it's very neat, right? So you can, when you get to the notebook, you can go through it. But the key takeaway, because we did different types of clustering, for soft clustering, unlike so this is very important to help you in the MCQ answer, right? So for soft clustering, so we have different types of clustering within the Gaussian mixed model. For soft clustering, unlike k-means, which assign each data points to one only one clear cluster, Gaussian mixed model assign probabilities, allowing partial membership. So you remember, where's that data we had? Okay, good. So look at the feature 1, feature 2. It was doing it based on soft clustering, not hard clustering. So we had the probabilities, and it was choose the probability of it being here or there. So that's soft clustering. It chooses probability. Why hard clustering? You just give it one phase. So soft clustering says it has certain probability of being in one class or another class. Good. So, yeah, then Gaussian mixed model assign probabilities, allowing partial membership. So for soft clustering, a data points could be partially in one group and partially in another group, but have more probability of being in one group. While hard clustering means it is either here or there. So Gaussian distribution assumes that clusters are Gaussian numerical. I'm not going to read this. When you get it, just read through it. Okay, good. Yeah, we have time. So we can use it in market segmentation with Gaussian mixed model. So banks, businesses, they use this kind of thing to cluster their customers, to put their customers in different clustering. So if you are using it in market segmentation with Gaussian mixed model, so the Gaussian mixed model performs soft clustering, meaning each customer is not strictly assigned to just one segment, right? So instead of GMM, instead, Gaussian mixed model provides a probability score. That's the soft clustering I talked about, for how each customer belongs to multiple segments. This is useful in market segmentation, where customers might share characteristics of multiple groups. Example, a customer could belong 60% to a luxury shoppers and 40% to bargaining seekers, right? What this is trying to say is that you cannot just cluster people as poor and rich. It's us that see it that way. Businesses don't see it that way. What do I mean? If you do hard clustering for your customers in terms of these are rich people, these are poor people, I will only share my luxury good to rich people, you may get it wrong. So let me go back to that slide to explain. All right. If you want to sell expensive clothes, all right, people will feel that I should only market my expense. Let's say I'm running an online boutique, right? Who do you think will buy your clothes more? By default, we feel it's these rich people, right? These people in this rich region. But do you know that sometimes people from lower region or poor region spend more on luxury things than rich people? Do you agree? Does that make sense? So instead of saying, I want to sell my rich stuff or rich jewelries, rich clothes, expensive clothes only to the rich people, you don't segment it in terms of rich and poor. You can have the two segments, but some people in this poor region will really want to access those expensive, luxurious lifestyle. I hope that makes sense. Okay, that's what that statement is trying to say. Okay, so these are some mathematical things. Exactly, Abdulrahman. So these are some mathematical representation of Gaussian mixed mode distribution for anybody who wants to look at the mathematical side of things. Okay, good. So we run this code and see. Okay, I'm not going to go deep into the mathematics of things, but yeah, this is the Gaussian distribution for the clustering of two different clusters of Gaussian distribution. Yeah, you can just read this through. These are a bit mathematical heavy, and I don't want to really go into it. So this is for like linear clustering. So if we go to non-spherical clustering, please, when you get this notebook, do your best to read all these things, right? It will help you a lot when you're answering the questions, because I made sure I created the notebook in such a way that just going through this notebook alone, you'll be able to answer the MCQ even without looking at ChatGPT. All right? Good. So do well to go through it. Good. So remember, these data points are just simple data points. It's easy to cluster, right? Now look at this data point. We have what do you call it? Where are they? Non-spherical clusters with GMM. So what do we mean by spherical? You can see that this cluster is round in shape. Is somehow round in shape, spherical, right? So similar to this clustering, you see spherical, a bit spherical, spherical. It's easier to spot the center of the cluster. It's easy. Now, when we jump to, things get a bit different from non-spherical clustering, right? So Gaussian mixed model is flexible and can model non-spherical data, unlike K-mean clustering, which assume clusters are spherical. So when you're trying to solve problems with data that are non-spherical, you use Gaussian mixed model because it performs better than K-mean clustering. So yeah, these are technical terms. I won't go through it. So, but let's look at this graph. All right. This is the original data set. We have two clusters. And remember, clusters must not be spherical. It could be non-spherical. So we have this cluster that is, what's this shape? Moon shape. I think that's what I can think of. This other side is moon shape. Now, this is the data. We know this is how the data is. So we want to see how the model will perform on clustering. It needs to cluster just this and just this. So you can see among the K-mean clustering and Gaussian mixed model, which one do you think is doing a better clustering? If you can look very well, which one do you think is doing a better clustering? It's difficult to tell. I know it's difficult, but with your eye, which we say did a better clustering than the other? Anybody in the chat? If you're going to rate the clustering, how K-mean clusters the data and Gaussian mixed model, which of them? Nosy, am I still on the call? Can you guys hear me?
Yes, we can.
Oh, okay. All right. Thank you, Abdul Rahman. It's difficult to tell, but if you look at the K-mean clustering, it just did a cycle. You can see that the cycle cuts here and cuts here. But you can see the K-mean, you see how down it went here? Or the Gaussian mixed model, it went a bit higher. So it's doing better than K-mean clustering, right? Good. So this is notes that compares why K-mean clustering is performing less better than Gaussian clustering, right? And yeah, I just use other examples, but I will stop here. Let me just jump to geospatial data. So this okay, let me just run the notes. These are still geospatial clustering, more explanation. Yeah. Hard clustering, soft clustering. These are more explanation, right? And good. So let me ask you a question. This new data point, which of the clusters will it belong? The gray, blue, or red? Off the top of your head. Anybody? It's closer to the red. Good. So unsupervised learning it doesn't have labels, right? But you have trained the model. So when the model sees new data points, it knows how to cluster the data points, right? So it's not doing like supervised learning prediction, but because of what it knows, when it sees new data points, it knows where to cluster them. So if you have a new data point like this, because of how the data are clustered, the model is closer to red. So it will group it in red. Good. So let's go to geospatial data. Let's see. So in geometry, for those of you who did geography, right? If you know geography very well, it will really help you in this geospatial. So there's a part of machine learning or data science which has to do with geospatial data, which has to do with those that look at maps, lands, satellite imagery, and all that. You work with such data. So the geometric column. So remember that geometric column I've always been talking. The geometric column in the geodata frame contains what? Geospatial data. So that geospatial data can store what? Points. That's cities and landmark, lines, road and rivers. Because if you look at Google Map, cities, landmark, houses, what do you call it? All these points that are like statue, monumental buildings, they're like points on the data, right? Then things like lines, when you see roads, long roads, rails, rivers, which other thing can look like line on a map? I'm thinking, I don't know. Which other thing can look like line on the map? Anybody? I'm just thinking road, rivers, rails, maybe. Yeah, rails. Mountains. Do mountains look like points or lines? I don't know. Then we have polygons, e.g., country or district boundaries. So when you look at the map of your country, you look at how the states or how the country is it demarcated or is separated? Okay, good. Mountains are line. Actually, because they are long, they are lines. Yes, yes. Thank you, Shelia. Mountains are line. We look at it from, oh yeah, what do they call that thing? Oh God, there's something they call this thing in geography. When they're trying to draw mountains, they'll just cycle or one funny shape. They'll start reducing the shape. Contours. Contours. Sorry, I just remember some of my geography. My geography teacher was very strict. I didn't really like geography. It was very stressful. Yeah, good. Then let's look at, let me just point out something. So I'll just run this code. I want to show you how exactly they become closer toward the peak, meaning how the wider parts are the lower valleys of the mountain, the closer parts are the peak. Exactly. I can see, remember your geography, Shelia. Good. What did I do? Good. So you can see I just used these data points to create a point, a line, and a polygon. So you can see this is a point, this is a line, this is a what did we say polygon can be used to create? Where was it? Okay, polygons, countries, and districts. Okay, so this is like a country or district on the map. This is like a road, a rail, mountain or something. Then this is like a point. What was point self? What do we say about points? Cities or landmark. Okay, good. So when you talk about geospatial data, it is just used to represent real-world geographical cities, entities such as cities, road, and regions. Okay. So we just want to see how we can create geospatial data, right? So we talked about types: point, lines, polygon. Then we use our geodata frame. We can use Folium for mapping. There are other types. I just put out this one. So it is in Python library for creating what? Interactive maps. So yeah, we import it. Sorry. Good. So this is just a simulation. So these data points I use are actual data point locations for Nigeria. I was using this country, Nigeria, right? So I was trying to draw on the map, and you can see, oh, sorry. It's very difficult to play around with this. Okay, good. So you can see, how many of you have, oh, I don't want to say this. Okay, let me use Google Map. How many of you have used Google Map and you are seeing the location? So you can see there is a shape that has to do with the polygon. Okay, I know this is triangle, but it's a polygon. So there's a point on the map, and you can see, let me come a bit closer. You can see the line. This is from Abuja to Lagos. You can see the line on the map. So this is how we use for all these geospatial drawings. You can see the map. Even on the map, you see all those lines, right? So this is code. Like this is actual Python code that we have brought to life using the geospatial. So this is just an example. And you can do a lot with this in any project you're working on, right? And so when you're using Google Map and you are moving, you'll be seeing where you are moving in real time, because they are using all this geospatial data and geopandas to navigate, make your navigations and all that, okay? So this is just an example of what. Now, this is how powerful Python is. So I want you to know that you are learning something very important and valuable in this course, right? It's what you do with it, okay? We may be giving things like raw material, but what you do with it going forward is very important. And remember, every area in life you can apply data to it, right? Your data presence is useful in any sphere. So the skills you learn in this program are not limited, they are boundless. It's just limited by how you limit it, okay? So when you get this notebook, I do believe that Nosy will make this notebook and these slides available. So these are when you get the notebook or the slides, you just click on here, you have the link to the notebook. Good. I hope this session made sense. I hope it was, you learned. I hope it was important for you. I don't see any question in the Q&A. So in the absence of any question, yeah, thank you, Nosy. You can run the poll. Please, if you find this session interesting, please just learn it. What I want you to do is get this notebook, play around with it, practice it, okay? Do your MCQ, submit before your deadline, but please practice what you have learned. It's very important, okay? I hope this session was helpful. I'll pass it on to Nosy to take the announcement and closing. Thank you, guys. And yeah, I'll see you when I see you.
Okay, thank you so much, Shegun. The session was quite informative. I was learning as well. But moving on, we have the learning and technical support. We have the Ask ALX data programs team. This is the eHub community space where you can ask any program or content related question. Please use this space for only this purpose. Then we have Fresh Desk. This is your go-to space for all program support, but ensure you log a ticket with the support team before you approach the program team. And then we have Answer Base, which is a channel that is dedicated for you to ask and get answers to complex content questions. Can I have the next slide? Coming on to the next step. So the webinar was quite informative, so I'm sure you will conquer it without even looking at ChatGPT. So please go and do your assessment, the model mix, the Gaussian mixture models and geospatial data MCQ. That will be due next week, Monday on the 8th of June at 9:59 p.m. GMT. Find our session recordings and resources on the program hub space. I'll post them as soon as we are done with the session so that you can rewind. Remember, you are not alone in the community. Engage with your squad, ask for clarity, and post your wins, challenges, and new insights on your squad spaces. To graduate, you'll need to pass at least 12 assessments out of 15 in the machine learning tracks. Please be mindful of that. If you don't have any if you don't have any assessments that you have completed, please do so that you can graduate. As Monday this week, you should have submitted at least 13 assessments. Thank you for your time. We will see you next week. Bye.
Unamongela ubuhlobo kaka sifuna kulo mhlaba inhlana malanga inhlana malanga umusa okubusa kuko konke kulo mhlaba izinkanyezi ezikhanyisa akaphakeni uhlobo khona nasezintabeni ukeleza wemfula kuletha ukuthula emoyeni emoyeni Unabonke lobu buhlobo kakasibona kulo mhlaba. Ihlana malanga, ihlana malanga.